In this video, I'm going to show you how to predict if a person has coronary heart disease using logistic regression, but we'll be using a Python library called the scikit-learn library. So, as you can see, the World Health Organization is estimated that there are 12 million deaths occur worldwide every year due to heart diseases. And then half of these diseases are in the United States. Other developed countries are due to cardiovascular diseases. So the early diagnosis of cardiovascular disease can aid in making decisions on lifestyle changes in high risk patients and in turn reduce the complications. So let's say you are being hired by a hospital to analyze their data set and then to predict if someone has a coronary heart disease, and then this will help the doctors sort of like give the patients medication or tips on how to change their lifestyle and diet so that they can reduce the risk of dying with heart attack. So the first thing we're going to do is we're going to import libraries such as pandas, which we are going to use for exploratory data analysis. We are going to use NumPy, which is a mathematical library, and then SciPy, which is used for statistics, and Matplotlib, which is used to visualize the data set. So here, this is my folder where I have this CSV file with Framingham. I got this file from Kaggle, and then here we are going to read the data from this file. We're going to read the CSV from this file, and then we are going to drop this column return education, and then we are going to use this dotted function from the pandas library to display the first 5 items in our data set. So in our data set we have these variables. We have the demographics, which show sex, which show if male or sex, which shows us if someone is male or female. We also have the age of the patient, so this is continuous, although ages sometimes are represented by whole numbers. And then we have like behavioral variables, like current smoker, whether if a person is a smoker or not. We also have the cigarettes per day, so these represent the number of cigarettes that the person smokes per day, averagely per day. And we also have like medical history, like whether or not the patient medical history or BP whether or not the patient was on blood pressure medication, like prevalent stroke, whether or not the patient had previously had stroke, like prevalent hype, whether the patient was hypertensive. And then we also have diabetes, whether or not the patient had diabetes. We also have the medical current, like the current information, like the total cholesterol level, which is a continuous variable. And then we have the systolic blood pressure, which is also a continuous variable. We have the diastolic blood pressure, which is also continuous. We have the body mass index. So the body mass index measures the obesity of someone. So, and then we have the heart rate, which is continuous, which is a continuous variable. We also have the glucose level. We also have the predict variable. So 10-year risk of coronary heart disease. So this is a binary classification type of problem. So if you have watched my previous video where I explained about the logistic regression, you should understand what is a binary classification problem. So a binary classification problem is a problem where we try to predict if something is positive, we represent it by 1. If something is negative, we represent it by 0. So in this case, if something has coronary heart disease, we represent it by 1, which is yes. If it doesn't have coronary heart disease, we represent it by 0, which is no. So now we are going to rename this column, the male. We are going to rename it as sex male. And then here we are going to check if there are any missing values. As you can see that on the cigarettes per day column, we have 29 missing values, and on the blood pressure we have 53 missing values. On glucose we have 388 missing values. So here you can see that here we want to to visualize the total number of missing values. You can see that the total number of missing values is 489. So since it is only like 12% of the entire data set, the rows with missing values, we then exclude it. We then drop these missing values, since they only constitute of 12% of our data set, which is almost like negligible. So the next thing is we want to visualize our features. So here we have the sex male distribution. So here you can see that the distribution of our disease is highly distributed on males and lowly distributed in females. And you can also see on the current smoker distribution, you can see that there are more males that are smokers than females. And you can see that you can also visualize the cigarettes per day, and you can see that they are also missing values. So we want to see if our data set is balanced. So as you can see, our data set is unbalanced. We have almost like 3,000, maybe it should be 3,200 examples, which show that 3,200 examples which show that they are negative examples, and we have almost like 500 positive examples. So we then visualize our data set. We then use the describe method from the pandas library to describe our data set. So now we move on to logistic regression. So logistic regression is a type of regression analysis and statistics used for prediction of outcome of a categorical or dependent variable from a set of predictor or independent variables. So if you want to know more about logistic regression, I advise you that you watch my previous video where I explained logistic regression from scratch. So here we just want to see the statistics. So here we import the scikit-learn library, and then we then create these features, new features. So these features contain the age, the sex, the cigarettes per day, the total cholesterol content, the systolic blood pressure, the glucose, and then the 10-year chronic heart disease feature. And then in this case we then chop off the last column, which represents the last column, which is our label. So these labels will represent if someone is heart disease or not. And then on the y, we then assign these labels on the y variable here. And then we then import from model selection from the scikit-learn library the train test split, and then we then split our data set into training set and test set. So we split our data set into 80% training set and 20% test set. And then we then import the logistic regression. We then import the logistic regression from the scikit-learn library, and then we create this instance of the logistic regression, and then we then fit our training set into our logistic regression, and then we then predict this y value from the logistic regression, then predict from our test set. And then we then import sklearn matrix to see our accuracy score, and then you can see that our model is 88% accurate. And then we then display this confusion matrix. So what this confusion matrix does, here it shows us the true positives. So the true positives are people who are predicted as having heart disease, and they actually have heart disease. So there are 658 true positive cases, and this which is represented by 4 is the true negatives. So these are people who were predicted as having heart disease, but they do not have heart disease. and then we have the we then have the false positive. We then have the false negative. So the false negatives are people who are predicted as not having heart disease, but they actually have heart disease. And then we have and then we have the false negative. So these are people who are predicted as not having heart disease, but they actually have heart disease. So in this case, our data set was imbalanced. So we do not use accuracy as a measure. We do not use the accuracy as a measure of how well our model is performing. We use other methods such as specificity and recall. So as you can see here, as you can see here, our we then import the binaries from the scikit-learn library, and then we then lower our threshold. We try different thresholds. For a threshold of 0.1, the confusion matrix is this. So if you have understood what I've said about true positive and false negatives, but in this case we want to maximize the likelihood of predicting if someone has a disease. So in this case, our most important, we want to see if someone is a disease, which is true positive. So we want to maximize that likelihood of someone having a disease. And yet then you can see with threshold of 0.2, we can see that the true positive is increased. When we have the threshold of 0.1, the true negative was 240. With the threshold of 0.3, we can see that true positive is 617. With the threshold of 0.4, the true positive is 652. And we can then plot what is called the receiver optical character curve. So what this does is there should be a line here that ranges from here up to here. So the further this line is away from the line, a diagonal line, if you draw a diagonal line, something like this. So if this curve is further away from the diagonal line, then the more accurate our model. So as you can see here, the accuracy here, the ROC accuracy score is 73%. So we can increase this accuracy by tweaking or playing along with the parameters, but I will leave that to you. You can research on the SKLA documentation to see how you can improve the accuracy of the logistic regression model. So thanks for watching, guys. I hope this video helped you understand how we can use the logistic regression model to predict if someone is at